Having found the midpoint for this line, we're now going to find the length of the line. Length can also be thought of as distance. You'll also heard this is a distance formula. The distance is equal to the square root of x2 minus x1, the difference in the x values, raised to the second power squared, plus the difference in the y values. We will come back and show how this is related to the Pythagorean theorem in a short while. x2, in this case it is 6. That is 6 minus x1 is 2. Plus y2, it is 5. 5 minus 2. Order of operations, parentheses first, 6 minus 2 is 4. 5 minus 2 is 3. Order of operations, exponents, 4 squared, 16. 3 squared is 9. The square root of 25. The square root, remember what this function is. What number multiplied by itself gives us 25? The answer is 5. For odd numbers, we'll have a calculator to solve for us. In this case, we have found that the distance is 5. Distance is length. What we have done in terms of our reference to the Pythagorean theorem, with the distance formula, it says x2 minus x1. That means this height minus this height. That's a measurement of this distance. That is x2 minus x1. That's one length of a right angle triangle. y2 minus y1 is a measure of our horizontal distance. That distance there, that is y2 minus y1. This is a rewrite of the Pythagorean theorem of a squared equals b squared plus c squared, where a is the hypotenuse, the distance. A is the hypotenuse, the distance. So we take the square root of both sides, and we say that a, the distance, is equal to the square root of b squared plus c squared. What is b? What is c? Those are these lengths. When you subtract y2 from y1, you get this length. When you subtract x2 from x1, you get this length. This is your right angle triangle. That is how the distance formula is the formula for the right angle triangle, hypotenuse, Pythagorean theorem.